SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe. You can download SpaceTime as a free twice-weekly podcast just about everywhere, including iTunes, Stitcher, Pocket Casts, Bytes.com, SoundCloud, YouTube, Audio Boom, and from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C. Coming up on SpaceTime, NASA's OSIRIS-REx blasts into space on a mission to rendezvous with a potentially deadly asteroid. Astronomers discover a rare fossil of the early Milky Way. And a huge population of brown dwarfs discovered in our stellar neighbourhood. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's OSIRIS-REx has successfully launched into space on a mission to rendezvous with the potentially deadly asteroid Bennu. The half-kilometre wide mountain-sized space rock, which passes uncomfortably close to the Earth every 6 years, has a 1 in 2,700 chance of hitting the Earth in the 22nd century. In fact, a 2010 dynamical study predicted a series of 8 potential Earth impacts by Bennu between the years 2169 and 2199. OSIRIS-REx was successfully blasted into space aboard an Atlas V 411 rocket from Space Launch Complex 41 at the Cape Canaveral Air Force Base in Florida.
Status check.
Go Atlas.
Go Centaur.
Go OSIRIS-REx.
Everyone is go. Standing by for launch. After liftoff, you'll hear the voice of United Launch Alliance's Marty Malinowski providing launch vehicle ascent data. 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of OSIRIS-REx. Its 7-year mission to boldly go to the asteroid Bennu and back.
Fire rates look good. Starting pump speeds and injector pressures are within family. Reading chamber pressures have plateaued, begun to ramp off.
Heard the voice of Marty Malinowski. The Atlas has begun a pitch and yaw maneuver to steer to its planned path, 28.5 degrees inclination from the equator.
SRB chamber pressure is almost plateaued at this point. Marty 180 injector pressures are good.
45 seconds in flight.
Whole program is complete. Boosters throttled down.
And the Atlas rocket carrying OSIRIS-REx has gone supersonic. Standing by to pass through max Q, maximum aerodynamic pressure.
Max Q, vehicle body rates continue to look good.
This is the point when the mechanical stress on the rocket reaches its peak because of the rocket's velocity and resistance created by the Earth's atmosphere.
Signatures look good. Current altitude is 14 miles. Downrange distance is 9 miles. Current velocity 2,488 miles per hour. Range track shows vehicle progressing down the middle of the range.
In about 30 seconds, the single solid rocket booster will be jettisoned at 2 minutes 19 seconds.
And booster has throttled back down. It's now 50% of its liftoff weight. Next major event will be SRB jettison, coming up momentarily.
And you see the solid rocket booster jettison.
Solid. Separation looks good. Vehicle has enabled closed loop Q alpha steering.
RD-180 engine continues powering the Atlas, Centaur, and OSIRIS-REx into space. Next major milestone will be booster engine cutoff, 4 minutes and 2 seconds into flight.
Valve has been fired. That system is now pressurizing to flight levels. Signatures look good. Current altitude 40 miles. Downrange distance 75 miles. Current velocity 5,988 miles per hour. Range track looks good.
About 1 minute away from Atlas booster engine cutoff.
Already went to burn well. Pump speeds, injector pressures within band. Vehicle body rates look good. Vehicle is now 1/4 of its liftoff weight. Coming up on our 5G throttle segment momentarily. And we have begun throttling to maintain 5Gs. Signatures look good. Boost phase cooldown is underway. And begun to throttle to 4.6 Gs in preparation for BECO. Boost phase cooldown is complete. And we have BECO. Engine shutdown looks good.
Booster engine cutoff confirmed. Standing by after
And we
spacecraft
have
separation for the Centaur single RL-10C engine to ignite.
We have ignition and full thrust on the RL-10. Coming up on payload for jettison.
Everything continuing normally. The Centaur engine producing 22,900 pounds of thrust, and it will burn for just over 8 minutes.
Centaur body rates look very good. The steering has been enabled.
And the payload fairing, which was covering OSIRIS-REx, was jettisoned. Everything continuing on the timeline.
55 minutes after launch, OSIRIS-REx successfully separated from its Centaur upper stage and deployed its solar arrays. The 2,110 kilogram spacecraft will orbit the Sun for a year, then use Earth's gravitational field as a gravity-assist slingshot to fling itself to rendezvous with Bennu in August 2018. Once in orbit around the asteroid, the probe will begin an intensive 2-year study program, surveying Bennu in unprecedented detail and eventually collecting samples for return to Earth in 2023. NASA mission managers have been careful to focus on the origins aspect of this mission, rather than the potential danger Bennu poses to the planet. The origins, spectral interpretation, resource identification, security regolith explorer, or OSIRIS-REx spacecraft will carefully map the asteroid, studying its mineral composition and structure, as well as the influence something called the Yukovsky effect has on the asteroid's movements. Asteroids like Bennu are regarded as remnants from the formation of our solar system 4.6 billion years ago. Scientists now suspect it was asteroids rather than comets, which were probably the primary source for most of Earth's water and organic molecules. And an uncontaminated asteroid sample from a known source would enable precise analysis, providing results far beyond what can be achieved by spacecraft-based instruments, or for that matter by simply studying meteorites. 10-1955 Bennu is a neo- or near-Earth asteroid. It's a carbonaceous asteroid from a group known as the Apollo family of asteroids. Put simply, Bennu's thought to be a carbon-rich rubble pile of boulders, rocks and gravel, loosely held together by its own gravity. The asteroid's carbon content gives it an extremely dark surface, which absorbs sunlight like an asphalt road on a hot day. Bennu has a rotational period of about 4.3 hours. As the asteroid rotates, the heat absorbed by Bennu is radiated away on the asteroid's dark side. This radiated heat acts like a tiny jet engine, pushing the asteroid in what's referred to as the Yukovsky effect. However, because Bennu is thought to have large internal voids and its structure isn't fully understood, scientists want to study its composition, its energy transport through the surface, its temperature and its topography to see exactly how the Yukovsky effect is influencing the asteroid's movements. OSIRIS-REx will measure its thermal activity to see how the material on the asteroid's surface stores and releases heat. It's thought coarser, rockier grain should absorb more heat from the Sun and release that slowly during the asteroid's night. On the other hand, fine-grained particles should lose heat fairly quickly once they're out of direct sunlight. In July 2020, after 2 years of intense study, OSIRIS-REx will perform a daring manoeuvre which will bring it close to the asteroid's surface. It'll then use its robotic arm to reach out and collect up to 2 kilograms of small rocks, dust and other surface material. The 6-metre-long spacecraft will then return to Earth, arriving in 2023, where it will deploy a small sample return capsule, which will parachute down to a landing in the Utah desert for collection and analysis by NASA scientists. Astronomers have discovered what they believe is a fossilized remnant of the early Milky Way. The system, named Terzan 5, is located 19,000 light-years away in the Galactic Bulge, the tightly packed central region of the Milky Way galaxy. When it was first discovered 40 years ago, Terzan 5 was classified as a globular cluster, a tightly packed sphere of thousands of stars. However, new research reported in the Astrophysical Journal shows it to be unlike any other globular cluster ever seen. Astronomers have discovered that the stars in Terzan 5 are of hugely different ages. Some of them are remarkably similar to the most ancient stars in the Milky Way, but this cluster also has a significant population of very young stars. Thus, Terzan 5 appears to be bridging the gap in science's understanding of our galaxy's past and present. This research therefore represents a possible new route for astronomers to unravel the mysteries of galaxy formation, offering an unrivaled view into the complicated history of the Milky Way. By combining data from NASA's Hubble Space Telescope, the giant 10-metre Keck Observatory on Mauna Kea in Hawaii, and the European Southern Observatory's Very Large Telescope in Chile, astronomers found very compelling evidence for two distinct types of stellar populations in Terzan 5, which not only vary in their composition, but also have an age gap of roughly 7 billion years. Astronomers first detected that Terzan 5 may have harboured two subpopulations of stars with different chemical abundances back in 2009. This new research has finally dated these two populations, finding that they weren't continuous but were dominated by two distinct bursts of star formation. Now, this requires the Terzan 5 ancestor to have large amounts of gas for a second generation of stars, and to be quite massive, at least 100 million times the mass of the Sun. These unusual properties all combine to make Terzan 5 the ideal candidate for a living fossil from the early days of the Milky Way. Current theories on galaxy formation assume that vast clumps of gas and stars interacted to form the primordial bulge of the Milky Way, merging and dissolving in the process. Astronomers think that some remnants of these gaseous clumps could have remained relatively undisturbed and keep existing embedded within the galaxy today. These galactic fossils allow astronomers to reconstruct an important piece of the Milky Way's history. While the properties of Terzan 5 are fairly uncommon for a globular cluster, they nevertheless are very similar to other stellar populations found in the Galactic Bulge. And it's these similarities which make Terzan 5 a potential fossilized relic of galaxy formation, representing one of the earliest building blocks of the bulge of the Milky Way. This assumption is strengthened by the original mass of Terzan 5, necessary to create two stellar populations. It's a mass similar to the huge clumps which are assumed to have formed the bulge during galaxy assembly some 12 billion years ago. In fact, some characteristics of Terzan 5 resemble those found in the giant clumps observed in star-forming galaxies at really high redshifts, that is, way back in the early history of the universe, some 12 billion years ago. This all suggests that similar assembly processes must have occurred both in the local and the distant universe at the epoch of galaxy formation. Somehow, Terzan 5 has managed to survive being disrupted for billions of years, and in the process has been preserved as a remnant of the distant past of the Milky Way. This discovery paves the way for a better, more complete understanding of galaxy assembly. However, the discovery also raises a number of questions, such as how did Terzan 5 survive destruction, and what was it which actually triggered that second burst of star formation? Astronomers have discovered a huge population of failed stars known as brown dwarfs in our stellar neighbourhood. The new findings, reported in the Astrophysical Journal, detected some 165 brown dwarfs during a survey which only covered about 28% of the local space environment. Brown dwarfs are important because they fill that gap between the largest planets and the smallest stars. They don't have enough mass to commence the core nuclear fusion process which makes stars like our Sun shine. To be classified as a brown dwarf, a celestial body would need to have about 10 times the mass of a giant gas planet like Jupiter. While the most massive brown dwarfs may have some limited short-term nuclear fusion, they generally only emit heat through gravitational contraction. Mind you, they can still have surface temperatures of around 2000 degrees Celsius, which is similar to spectral type M red dwarf stars. But there's much about brown dwarfs which remains unknown. So by discovering new brown dwarfs, scientists will be able to better quantify the frequency with which they occur, both within our solar neighbourhood and far beyond. So by knowing the abundance and distribution of brown dwarfs, astronomers have key information on the distribution of mass in the universe, and also on the mechanism of brown dwarf formation. For example, whether they form in isolation or are instead ejected from larger planetary systems. The Indian Space Research Organisation has successfully launched its fifth space mission of the year, carrying a new weather satellite into orbit. The Geosynchronous Satellite Launch Vehicle, or GSLV, blasted into orbit from India's Satish Dhawan Space Centre in Sriharikota on the Bay of Bengal.
15 seconds.
GS1 ignition, cryo-arm, key locks enabled.
10, 9,
UPS cut off normal.
8, 7, 6, 5, 4, 3, 2, 1,
L40 ignited.
+1.
Yes.
+2.
GS1
L40
ignited.
performance
Vehicle
normal
liftoff.
and S130 ignition. Vehicle lifts off from the launch pad.
+7. +8.
शानदार तरीके से
+10 seconds.
यान ने अपनी यात्रा शुरू की, उड़ान स्थल को छोड़ा। एक बहुत ही शानदार उड़ान, प्रथम चरण पूरी तरीके से प्रज्वलित।
12 kilometer altitude. In fact, if you look at the sequence of the first stage, we will have the L40 burning for nearly 145 seconds, whereas the core solid motor burns for 100 seconds. After the burnout of the S139, the L40s will...
The mission, designated GSLV F-05, carried the INSAT 3DR weather satellite into a 230 kilometre high geosynchronous transfer orbit. The 49-metre tall three-stage GSLV uses a core stage powered by a single S139 solid rocket engine and 4 strap-on L40H Vickers 2 liquid-fueled boosters. The core stage is jettisoned after 2.5 minutes of flight, leaving the second stage, powered by a single GS2 Vickers 4 liquid-fueled rocket engine, to take over the haul to orbit for the next 2 minutes and 19 seconds. The third and final stage then takes over the mission for the remaining 12 minutes of flight to orbit. The GSLV launch vehicle used for this flight is a new Mark II variant, which uses an Indian-developed CE 7.5 cryogenic third-stage engine instead of the previous Russian engines used on the earlier Mark I versions. Once in its transfer orbit, the INSAT 3DR satellite was deployed using its own onboard propulsion system to reach a geosynchronous orbit some 36,000 kilometres above the equator. The 2.2-tonne meteorological satellite is based on the Indian Space Research Organisation's 1-2K BAS and carries enough fuel for a 10-year lifespan. The satellite's equipped with a multispectral imager, producing observations of the planet every 26 minutes in 6 different wavelength bands. These monitor infrared surface radiation, precipitation, sea surface temperature, snow cover, and cloud motion winds. It's also fitted with a 19-channel atmospheric sounder, which is designed to provide vertical profiles of temperature, humidity, and ozone in one visible light channel and 18 narrow spectral infrared channels. INSAT 3DR is also equipped with 2 transponders. There's a data relay transponder, which can receive meteorological, hydrological, and oceanographic readings from remote sites, which can then be relayed back to mission managers by extended C-band. And there's a search and rescue transponder, designed to pick up and relay alert signals sent by distress beacons activated by maritime, aviation or land-based users. The signals send coordinates to search and rescue services operated by the Indian Coast Guard, as well as Indian aviation, shipping and defence services. The INSAT 3DR is the second satellite in the series, the first being launched by Arianespace aboard an Ariane 5 rocket from the Kourou spaceport in French Guiana back in July 2013. The mission was also the 10th launch using a GSLV rocket since its maiden flight back in April 2001. The last GSLV flight was almost exactly a year ago, while the next mission for the GSLV launcher is slated for May next year, when it will launch the GSAT-9 telecommunications satellite. The Indian Space Research Organisation says it's now planning to launch at least 2 GSLV rockets every year. And finally for now, a new issue of Australian Sky and Telescope magazine has just hit the newsstands. And joining us now with the details of this month's issue is the magazine's editor, Jonathan Nally.
October issue of Australian Sky and Telescope is out and about right now, and in this we look at all sorts of things in this issue. One of the really interesting things, though, is we have a big article on what they call big data, or big data. This is a common term you hear in all sorts of things to do with computing these days, and computing is just as big in astronomy as it is in everything else, because the new breed of telescopes that are being built right now, and they're going to be coming online in the next years and decades, are going to be producing colossal amounts of data, so much so that, in fact, astronomers already know that they won't know what to do with it all. Certainly, they're facing a situation where, for the first time, really, they're not going to be able to store all the information that they get in certain aspects because it's just uneconomical. You could theoretically build a huge data centre big enough to store all this stuff, but you wouldn't have the money to do it.
I think the current plan is to have all sorts of algorithms which will pick and choose what to keep and what to throw out, because you simply haven't got the manpower manpower, the person power, to go through all that.
That's exactly right. So they're going to have to sort of use these computers and the computer programs to analyse it on the fly and pick out the stuff out of all the data that you're looking for or that might be interesting and keep that and dump all the rest. Now, that's not going to be the case for all of the data and all of the programs, but for some of them that produce enormous amounts of it, they're going to have to do that. But then who knows? I mean, sometime down the track, they might invent some brand new type of computer storage that is really cheap and you can store lots of stuff.
Well, what they're working on now is called the atom drive or the atomic drive, and it is where you use individual atoms to store data. And theoretically, on something the size of a postage stamp, you could store the entire literary works of the human race.
Well, it'll be nice if that happens. I look forward to that sort of thing. I guess people of our generation, Stuart, we've heard all these sorts of things before, haven't we? Holographic memory and all sorts of things. We're going to the storage density of computers has come down, or increased, I should say, unbelievably in our lifetime, and the price has come down amazing. In fact, I think I stumbled across a website once, and it had someone had worked out what the cost of a gigabyte of memory cost or would have cost if it had been available during all the years when computers have been around since like World War II all the way up. So
that's quite interesting. Yeah,
there was something crazy like back in World War II, if you could have made a gigabyte worth of memory, it would have cost you $470 million for 1 gigabyte. But what's a gigabyte worth of memory now?
And now, who buys gigabyte memories these days? Everyone's buying terabyte and petabytes, the next big one coming up for home computers. That's sort of where we're heading for now.
Well, a lot of people listening have probably got, I've got them here sitting next to me right now, some external hard drives on my computer, 1.5 terabyte, that kind of thing.
I had a drive unit with 8 500 gigabyte hard drives in it, and now I've got 2 pocket-sized 4 terabyte external hard drives.
Well, those hard drives, the square kilometre array telescope that's going to be built, or that they're starting to build, when it's up and running, it's going to produce so much data that you need thousands of those external hard drives. Thousands and thousands and thousands of them to store all the data. In fact, someone's worked out that, those Blu-ray discs, you would need 92 million Blu-ray discs to store all the data that's going to come out of the square kilometre array. And if you stacked all of those on top of each other...
That's one of the biggest research projects of the square kilometre array. It's not just taking in the radio frequencies from deep space, it's working out how to store all that stuff, both in Perth, also in South Africa, and of course in Manchester.
Yeah, well, this is the big problem they're facing. So that much data, so 92 million Blu-ray discs worth, if you stack them all on top of each other, they'd reach more than twice the height of Mount Kosciuszko. Just an enormous, staggering sum of data. So anyway, that's for the professional astronomers who to worry about those sort of things. Us mere mortals, so what can we do? Well, if you like taking photos of things in the night sky, and particularly if you like taking what they call deep sky photos, which is through a telescope, where you're looking at galaxies and nebulae and those sorts of things that are out beyond our solar system, what they call deep space or deep sky, then we have a really good article on how to use a piece of software called PixInsight to stack multiple photos together to get a better result than you would get with just single photos on their own. So you can take multiple photos of a particular thing, say a galaxy, and then you use this PixInsight program to stack them all together, and it will line them all up so that you've got all the stars lined up and everything, so nothing's blurry and nothing's got double images, and it does it all automatically for you. So it's pretty amazing stuff. So astrophotography these days is so much easier than it used to be.
I take it you've got to do them all in a reasonably quick amount of time, otherwise you get parallax issues.
Yeah, you do. But look, it can account for all sorts of things. It can account for different lenses and all sorts of stuff. So it's remarkable how the software can adjust the photos to make them all fit together. So, and you get some tremendous... the sort of pictures you get these days are better than the ones that the professional astronomers used to take.
Well, these days, professional astronomers use amateur astronomers to back them up a lot of the time to get additional images of specific target objects.
Well, they do, because a lot of clever people out there, and they've got really good gear, because the gear is now affordable. I suppose gear was available in earlier days, but it just was unaffordable. So now anyone really can afford to do that if it's their hobby. Some other things you might want to get, your hobby is astronomy, and you can afford them, and you can, because everything's pretty affordable these days, is some tremendous eyepieces. We've got a test report or a view on some fantastic eyepieces that give you a 100-degree wide field of view when you look through them, and that's just enormous, 100-degree wide field of view. Eyepieces are the things you plug into the viewing end of a telescope, and they're the things that give you the magnification you want, and then you also get ones that have different fields of view, if you like. Some have got narrow fields of view, and some have got wide. These particular ones, 100-degree wide field of view. And with these particular eyepieces, people say when they look through them, you actually feel as if you're floating in space. So if you look at Saturn or something through one of these eyepieces, it's just like you're out there as an astronaut in a spacesuit, just floating in space with this big planet in front of you. So pretty amazing stuff. So if you're looking at getting some new eyepieces for a telescope, well worth giving these ones a look, I think.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, and from spacetimewithstuartgary.com. The show is also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C.
This is SpaceTime with Stuart Gary. For more, you can follow us on Facebook, Twitter, and Tumblr. Just search for SpaceTime with Stuart Gary.